Hi all, welcome to part 10, module 2 computer networks. So we were discussing the pipelining concept, the capacity of the link and to utilize it fully. So instead of sending a single packet over that cycle time tt plus 2 tp, you can try sending more packet. How many maximum for getting 100% efficiency? It has to be tt plus 2 tp divided by dt. So that is what we see. Let's understand this somewhat more detail with an example. So here what you can see that simple communication media is being assumed. So let me take the pen. Yes, and where this is the frame, total frame, and say the frame will be having some L bits and the media will be having some B bandwidth. So this transmission time is found to be 1 millisecond. So hope it is clear for you. The frame transmission time is assumed to be 1 millisecond. Okay, so just see this. And okay, what is the formula for tt? Tt is length of the frame divided by bandwidth of the media, and say and those things are not given. By dividing all this we got the value as 1 millisecond. Now the propagation time is taken to be 1.5 milliseconds. So the propagation time, distance by velocity, for first they calculate the distance and then the taken the velocity of the signals, they calculated it to be 1.5 millisecond as the propagation time. Now tell me what is 1 plus 2a. So the sender window size, the window size of the center side, the window size is found to be 1 plus 2a. So what is this value? What is a? A is the frame transition divided by propagation time by transition time, right? So tt, the actual formula was like a tt plus 2 tp divided by dt, and you divided numerator and denominator by tt, and you get this formula for the center window size. So and this tt by tt 1, tp by tt is taken as to be a. So what is this value tp by tt? So if you are getting confused with any parameter, please watch previous video, otherwise it will not be clear for you. What is tp? 1.5 millisecond. And what is tt? Frame transmission time, it is 1 millisecond. So as both are millisecond, it cancels each other. So the parameter, unitless quantity a is found to be 1.5. So substituting a as 1.5, the sender window size is found to be 1 plus 2 times 1.5, and that is equal to 3 plus 1, 4. That means the sender can transmit 4 frames instead of a single one, as what is done by in stop and wait. In stop and wait, the total time taken for transmission and reception of the acknowledgement all together, the cycle time of a single frame is tt plus 2 tp, right? What does it mean? The tt for transmitting that frame, and tp for its propagation, and another tp for the acknowledgement to come back. At least this, actually processing time, acknowledgement, transition time, many other things were also involved, but we approximate to this parameter as the dominating one. So during this time, in our what called stop and wait protocol, we send just a single frame, right? But now it is saying that the pipelining concept saying that instead of single frame, if you are able to send 4 frame during this period of time, that is 1 cycle time, you will get maximum efficiency. In the sense, when you send 1 frame instead of 4, actually we were able to send 4 during this whole time, right? And stop and wait, you will send a single frame and you will just wait for acknowledgement till acknowledgement is coming back. But instead of that, if you send 3 more, totally 4, it will be giving you maximum efficiency. In that sense, if you calculate the efficiency of stop and wait, you will get it to be 1 by 4. What does it mean? Actually I can send 4, but instead of sending 4, I am just sending 1 packet only during that entire duration of time, and the remaining time I am simply sitting idle. I am simply waiting for the acknowledgement. So that makes stop and wait highly inefficient. So what is this? 25%, right? So only 25% efficiency I am achieving with the stop and wait. And if you want, you can cross check with the efficiency formula that we learned there. What is the formula we learned for efficiency in stop and wait? It is like so hope you remember, otherwise you please go stop and wait efficiency derivation, that particular video, and watch it. So efficiency is found to be 1 by 1 plus 2a. and this 1 plus 2a is our 4, like what we obtained, right? So the same formula, that formula also you can apply. You will find that the efficiency is 1 by 4. So this is another way of explaining that efficiency. Instead of 4, I am sending only 1. So I am getting only 25% efficiency. So how can I improve my efficiency? Definitely by sending 3 more packets instead of 1. So totally 4 if I am sending, I will get good efficiency. So what I am going to do is I am making my sender window to be size 4. I mean 4 frames is in my window. So once I send this 4 frame, if when I am getting the acknowledgement for the very first one, I will slide the window and I will accommodate 1 more frame. So that is the way I am going to proceed. So actually for sending my first packet, so the frames or the packets were numbered like 0, 1, 2, 3. So packet or frame, simply in data layer particularly you can use the term frame, but packet is a general term. Okay, use anything. And this frame 0 I send, say the time I spend for sending that frame 0 is just 1 millisecond, that is its transmission time. And then actually this acknowledgement for frame 0 is supposed to come. So in between this data propagation time and its acknowledgement propagation time, totally 2 TP, which is found to be 3 millisecond, and 3 millisecond, instead of waiting, I am sending 3 more packets, because for sending 1 packet I am spending only 1 millisecond. That is why during 3 millisecond I can send 3 more packets, right? Then I am waiting for the acknowledgement of the very first one. And so this is how the pipelining concept is implemented, right? So now hope this example is clear. Now once I get acknowledgement for packet 0, what I will do, I will send 1 more packet by sliding my window by taking the packet with the sequence number 4, or if you want you can reuse a sequence number concept, we will deal separately. So right now you assume enough number of sequence number, so 4 more you can send, like a 4th one you can send. And when you are getting acknowledgement for this one, you can send a 5th one, like that. So that pipelining concept. Now let me clear this, and the same thing I listed out here. The maximum packet that can be transmitted in a total cycle time, that is sender window size, is found to be 1 plus 2a, and in this example the transition time 1 millisecond, propagation time 1.5 millisecond, and this 1 plus 2a, if you calculate like what I done before, you will get it as 4. That means a sender window, a window of 4 packets which we have transmitted but not yet acknowledged. So that is the meaning of sender window. So in the picture given here, after sender has transmitted the packet 0, still it is having time, that is the waiting time that it is utilizing for the sending other packets. So it will immediately transmit packets 1, 2, 3. Acknowledgement for 0 will be arriving after 3 millisecond, because 2 TP plus TP, right? That 3 millisecond, 2 times 1.5. So at that time it is utilized by sending 3 more packets. So in stop and wait, during this 4, the time taken for 4 units of data, we are just transmitting a single one. So that makes its efficiency to be 1 out of 4, that is 25%. Now we are improving it. It is now like a 4 out of 4, somewhat 100% efficiency. But you can't achieve 100% in the sense we didn't consider any error cases here. So when there are error, accordingly the efficiency will decrease. So that is the practical scenario. So for the time being, you got how things are working. So this is the pipelining concept. And in addition to that, the sliding window pipelining with sliding window, generally we call it a sliding window protocol. Why so? Because that window is somewhat sliding over this sequence of frames. So from that it is given the name. So like what I already told you. So window slided on receiving the acknowledgement. Actually sliding in the sense, whenever 0, 1, 2, 3 it is sent together. Whenever it is getting acknowledgement for 0, sequence number 0 used again, and 2 bits are required to send the data. So it is something different. So now in the window you can accommodate 1 more frame, right? That 1 more frame you can give a sequence number 4, but instead of 4, why don't you reuse 0? So that is the idea, because the 0th frame is now reached the receiver successfully and is being processed, and it is not at all be there in the picture. Only after getting acknowledgement for the 0th frame only, I'm going to send the next one. So next one means the fifth packet, right? Here this is not the way. One more things, because the window is of size 4, right? Now the window has to slide, and if one more thing is there, then it has to take that also into the window. So the fifth packet is now ready, and what is the sequence number that you can give to the fifth packet? Why don't you reuse the sequence number 0? So that is what we are trying to say, because we always want to minimize the sequence number to minimize the number of bits used in the header, right? Otherwise it will be something that will not fit in our control. So we want to minimize. So minimize in the sense minimum this 4 is needed, because these 4 are in transit at any time. So those 4 you have to differentiate each other at the receiver side. They may take the same route or different route. They may come in any order, like that, many things. So these 4 you should give 4 different sequence number. That is for sure, right? Now what about the fifth one? Can I use this 0? Because fifth one I am sending only after getting acknowledgement for 0th one, and that time the 0th one is completely consumed by the data link layer of the receiver, and it is handed over, the payload is handed over to the higher layer. So this is not at all be there in the picture, so you can reuse at this point. So in this particular example, the window size, the center window size is found to be 4, and the number of distinct sequence number is found to be 4. So how many bits can be assigned for representing the sequence number? 4 different number, right? You can use the number of bits per sequence number will be 2 bits. Why it is so? Using 2 bit you can have 4 combination, 0 0 0 1 1 0 1 1. You can differentiate 4 different packets with the 2 bit sequence number. Nice. So that is the idea, but there are some problem with this 4 different sequence number that we will see when we move on to this is something. So far we are in the theoretical structuring only. When we move on to the more practical protocol, we will see what is the problem here, and accordingly we will slightly modify this sequence number part. Okay, but for the time being, without any error situation and all, this is found to be a good value, a good minimum value. So after we have received the acknowledgement number for packet 0, the window slides and the next packet can be assigned the sequence number 0. So that is what we are trying to say. But if you are giving 0, some problem will be there when it comes to a practical scenario. That also we will see. For the time being, with an error-free channel kind of assumption, this works fine. So the sequence number which have acknowledged can be reused, right? That is what happened. The 0 we reused, so that the protocol header size can be kept as minimum by minimizing the number of bits in the sequence number field. So some theoretical background of it. The maximum center window is 1 plus 2a. In the previous example it was 4, where a is tp plus tt, and 1 plus 2a, what value you are getting, if it is 4, that could be the minimum sequence number required. And this is from the center window point of view. That is very important. But when it comes to a practical protocol with the receiver window, so that we didn't touch so far, the receiver window will also we will consider, and that time it will be slide. So from the center window point of view, or from the pure concept of pipelining point of view, these things are correct, but we will vary this protocol little bit to make it work better in the practical scenario with error cases, and that time this thing will change. Okay, so this is a general concept without any without considering the receiver window at all. So this is about center window. So the maximum sequence number required is 1 plus 2a. So in the previous example it is 4, right? Now all the packets in the current window will be given the sequence number, right? 0 1 2 3, right, like that. So the number of bits required will be 2 bits, right? So what is that? 2. So that is nothing but logarithm of this 4 to the base 2 is 2, right? So this concept you know, right? So log 4 can be written as 2 power 2. So this will be 2 log 2 to the base 2. Log 2 to the base 2 is 1. So it is 2. So that is how I am getting. So that is nothing but this 1 plus 2a. Take the logarithm. Why you are have to take the ceil function is because instead of 1 plus 2a, suppose you are getting as 5. Okay. So if it is 4, it will work, because 4 you can write like 2 power 2. Now if you are getting it like 5, so then what is logarithm of 5 to the base 2? You take your calculator and calculate for the time being. No need to go for shortcut. So 2 power 2 and all you can write like this, but for 5 you have to find, and you will get a value like is 2 point something, right? But even though it is 2 point something, maybe just see, so some fraction will be there, this 2 point something, this 2 point something, whether you have to take as 2 or you have to take as 3. So that is the question. Even though it is say 2.1, it is not round off actually, even though it is 2.1, 2 point something you are getting, definitely it has to be taken to be 3 because 2 bits are not sufficient now. So this is seal function. Similarly, if 2.1 you are rounding to 2, that will be floor function, different one. So here you have to take seal function, which you may be familiar with your C programming and all. In math header file this is available. This seal will give you this 2.1 seal of it will be 3. So that means 3 bits are now minimum needed because 5 different sequence numbers you have to generate. Using 2 bit you can generate only 4 distinct combination, but now you want 5 distinct combinations, so you need one more bit, something like this you can give, and the remaining field will be unused, right? Or the other set of 5 you can use. So that is the thing. So that is why seal of log this will be the number of bits in the sequence number field. Again, this is up to the pipelining concept only, and without taking any assumption for the receiver window. Only about sender window we are having these derivations with us. See now another thing, but sometimes the number of bits in the protocol header is predefined, but here 2 bits or 3 bits that we calculated. But now in a different scenario, suppose the 1 plus 2a you are getting to be, so when you calculate this 1 plus 2a you got like some 1024, right? So when you are taking this you will get as 10. So 10 bits you want. But when you look at the actual protocol, because once you design a protocol, the header, everything you will fix, right? So when you fix the protocol header, and the protocol is slightly varied, and with that varied protocol and with not about the protocol, the transition time, propagation time, together everyone decide this factor, how many bits are needed, right? So maybe in a better infrastructure you got it to be 10 bits, but once you design the protocol, see, unfortunately in the protocol header, this header field and the payload field, you allocated say only 8 bits for this. I mean, sequence number field is 8 bits. That is something fixed in the protocol design itself, and to that particular protocol you are supposed to use your modified algorithm. I mean, not the modification of the algorithm, the infrastructure. With a better infrastructure now we are running the protocol, but in the protocol we have a restriction like the field is something predefined, say to be to 8 bits. Now in that case you can't take this 1024 as a window size, because even though you are taking 1024 as a window size, you can't accommodate it, because the sequence number 10 bits you are now not able to provide. You can give only 8. So what you can do is you can reduce the sender window size as per this 8, because window size, how many frames are there in the window, that many distinct sequence number is a must, otherwise it will go to some erroneous situation. So that is a minimum thing, because those many things we are going to send at a particular time, right? So we have to differentiate them. So when if it is 8 bits, then 2 power 8 is what? 256. So now we are supposed to use this sender window size to be 256. So what is happening is actually sender window size, one formulation we have is 1 plus 2a. That is something determined by the underlying infrastructure we are having. Now, you know, in the protocol header, if the sequence number field is just n bit, the protocol is saying so, I can provide only n bits for the sequence number field. Then using that n bit, 2 power n sequence numbers are possible. So now see which is minimum. That is what I can provide as the sender window size. So this is the kind of limitation we are having, because even though the infrastructure is better accordingly we need an upgraded version of the protocol. But if it is not available, upgraded in the sense that increase in field is needed, but that is not means if you keep on increasing like that, it will lead to some other issues. So we have some limitation with such constraints. We are supposed to decide the sender window size. So definitely if it is 1 plus 2a, then only you will get that 100% efficiency without any error situation or in an ideal case. So practically that is not the case, because as the sequence number field is restricted, accordingly you are forced to reduce the sender window size. So in the previous example itself, that 4 is going to give you 4 by 4 100% efficiency, but due to the sequence number field, suppose sequence number field is just a single bit, 2 power 1, only 2 you can send as the sender window, right? And that time 2 by 4 it will be 50%, efficiency will decrease. But definitely it will be better than stop and wait, because stop and wait we could achieve only 25% in that previous example, right? So that is the whole thing. So hope you get an idea now. Let me clear the screen. So all the things why I'm giving this much detail, no, from your exam point of view. First of all, it is a 3 credit subject, so just that concept is enough for you for your university exam. But why I am spending this much time and effort is because I want you to be good in this subject, in the sense for any competitive exam like GATE and all, you should score very good. And also for the placement, campus placement, maybe in the core companies, if they are dealing with the computer network administrator, that kind of job, you need a sound understanding of all this. Okay, so with my knowledge, and I collected maximum information and I am giving you. Definitely some limitations will be there in my class. If you have any suggestion, that you can tell me in our discussion class, or you can contact me personally and you can tell me, and you can also add more information that is coming into your mind. Okay, so this is something from the reading I done. I'm explaining all those things. And also some of the gate questions also, when I tried to solve, I felt like in knowledge should be like this, then only we can attend all the problematic questions. So that is why I'm going this much detail. So the exam point of view, it's enough for you to just understand the concept and study in a subset of what I am teaching you in the class. Yeah. Yes, something missing here. Yeah. So what we seen is, if it is predefined, the size of the sequence number field in the header will also determine the maximum number of packets that can send in a total cycle time, that is TT plus 2TP time. So if capital N is the number of is the size of the sequence number field in the header, then we can have only 2 power n sequence numbers, right? So the center window size will be now minimum of 1 plus 2a, that is from the formula, and 2 power n. So what is minimum? Accordingly you have to go with. And accordingly, if the capital WS this denote the center window size, then take logarithm of it and take seal. That will be the minimum number of bits in the sequence number field. Now this is something I just want to highlight at this point. So here we saw the center window concept only, or the pipelining concept in general. Now the receiver window, there are when it comes to practical implementation, we have to consider the receiver window also, and that is a slightly different concept we will see in our subsequent discussion. And where we have 2 practical protocol, that is a variation of the sliding window, the sliding go back and sliding window protocol, and the selective repeat sliding window protocol, that are used to implement the pipelining practically. And in that case, we will consider something different called receiver window also, and accordingly the sequence number concept will slightly change. Okay, and that we will see when we discuss that, and particularly when there is error situation. Otherwise it will work fine. Thank you.